The LG Procast is intended for informational and entertainment purposes only. The views or opinions expressed by the podcast hosts and guests do not necessarily reflect the official position of LG. For the latest and most accurate information about LG products, please consult relevant product manuals and related documentation.
Welcome everyone to another LG Procast. I'm Terry Frisenda.
And I'm Phillip Craigbaum. Thanks for joining us today. Today with us, we've got Alex Meaney. He is the founder and owner of Mean HVAC. Welcome, Alex.
Hey, thank you. Pleasure to be here.
I appreciate you joining us today. So today we wanted to get into the topic of residential load calculations. So we brought Alex along to bring his experience and his vast amount of wisdom to the table with us today. So again, thanks for being here. So Alex, if you want, maybe just share a little bit about your background, your history, and what you're currently doing.
Sure. So I started in the HVAC industry by working for RightSoft, actually. If you're not familiar, RightSoft is one of the two companies that's been around the longest doing load calculation, duct design, that kind of thing. The owner of the company, Bill Wright, sort of tricked me into working for him. It's kind of a long story, but hired me as a temp. And I just kind of hung around, being the guy that you could train to do whatever you really needed. And so they put me in sales, they put me in marketing, they put me in tech support, they made me the trainer, just wherever they needed to fill a hole. But eventually they made me their trainer, and that stuck. I was their trainer for about 16 years. The first, actually, the trainer wasn't fired. He quit. They sent me out on the road with him to watch his class, and he put his resume out like that day. And it turns out
what was coming.
They actually had no intention of getting rid of him. They just kind of wanted to have a backup. Yeah. Or at least that's what they told me. But my first training class, I walked into the office on a Monday morning, and the president of the company and head of human resources were standing in my office when I got there. And I was like, oh man, I've had a good run, I guess. That sucks. And they were like, Marco quit. We bought you a plane ticket. You're going to North Carolina. Here's some cash. Go home and pack a bag and beeline it to the airport. You got about 3 hours. And before I left, I was like, okay, so what do I need to teach them? Because there's kind of a lot. And the funniest thing, the assurance I was given was, oh no, don't worry. They know how to do load calculations. You're just there to teach them the software.
Yeah, that may not have been true.
No.
Sure they do.
Yeah. Every third question was, what am I saying? Third, 2 out of 3 questions had to do with the manuals, and the actual process. But luckily I worked for some really smart people who gave me access to other smart people if they didn't know what they needed to know. And so I was trained by HVAC contractors. They trained me either by showing me things. I would trade work on weekends to, have them show me stuff, and I would show them the software into things. And they would train me by asking me questions and forcing me to get answers that, that's sort of my superpowers. You only have to tell me like once, maybe twice. And it continued on like that for years. I still get questions and find things out that surprise me, or that I don't know. If you want to always be learning, you pick the right industry. If you're listening to this podcast, let me tell you,
for sure, things
are always, either things are always changing, or you could always learn it a little bit deeper.
Yeah, both.
Both of those things are true, and they're probably true of a lot of industries, but it does feel like ours is just a little bit heavier on that kind of thing. So I started Mean HVAC mostly at the beginning as sort of the RightSoft trainer. You just paid me instead of them. Fly around the country teaching classes. I have an online learning platform. It's on demand. It's actually better than the in-person class. The in-person class has one advantage. It locks you in a room with me. Now, that can be a distinct advantage for those of us who have time or have trouble carving out time for ourselves. I'm not discounting that, but In person, I don't have a rewind button. I do. You can ask me questions, and I will, cover whatever you need until we have it and move on. But the other problem with the live class is it's 2 days, and you're learning everything you can about HVAC design in 2 days. Your brain eventually fills up.
I absolutely remember that class. That's where I met you.
That's right.
That's right. You were putting a class on in New Orleans, and my boss, I was fairly new to the industry, said, "Hey, head down to New Orleans and take this class and learn to do load calcs." And I came back just going, "Holy smokes, what did I just step into?"
Yeah, there's a lot. Like everything leads to kind of another thing. I find the biggest problem, one of my kind of pet peeves, is when we train new people in this industry. We have a tendency to forget to tell them, hey, this thing that I'm telling you right now isn't exactly how it works. We're just going to use this for now. I have no problem with using rules of thumb as a bridge to get to being able to, diagnose, fix, work on air conditioners. They work great for what they are. But it's when we tell them, this is how it works. This right here. This is exactly how it works. And we don't give them any indication that later we are going to tell you that's not how that works. We put a 36 in it, so it must be a 3-ton. And that can be really problematic when, you put a lot of confidence in that knowledge early on. So that's why I made the online stuff, so you could spread it out over weeks if you wanted, or you could sit down and take it all in 2 days. It's up to you. But it's also, I'm allowed to be a little more thorough when I don't have the structure of, I have you for 2 days and that's it. So
yeah, for sure. Well, go ahead and plug your website. What's the name of your site where they can go get that knowledge? It's
meanhvac.com. Pretty simple.
Cool.
And a lot of what I'm doing lately is trying to find ways to bridge the gap. And I think this is where this conversation will end up going. Trying to find ways to bridge the gap between building science, building performance, and HVAC. They are 100% tangled up in each other. It's really, really hard to do one without the other. And man, there's plenty for us to know on the HVAC side of things. So it'd be nice if we could just cherry pick some of that building science stuff to find out, because we're one of the very few, I think we might be the only trade on a major basis who gets blamed for everybody else's mistake. Right? Like the insulators mess up, anybody can mess up in the build process, but if the homeowner's not comfortable, it must be my fault.
Well, that's an interesting comment, because the conversations I have with builders across the country almost always center around when the home closes and everybody moves in. The first call, if the plumbing toilet isn't leaking, the first call is, "I'm not comfortable in my new home."
Mm-hmm.
And it's just gone on for years and years and years. So I certainly respect that opinion of yours.
Yeah, it's and it can be caused by so many things. And on the flip side of that, you've got the retrofit world where, okay, you could improve somebody's situation by giving them a better system or selling them a better system. But if their problems aren't coming from their system, right? If they're cold because the house is super leaky or the duct system is, inadequate, or, there's a lot of things that could be causing issues. And not being the guy who, every problem looks like a nail because all I got's a hammer. It can be good for, even if you don't intend to use any of those skills, just to level set, right? Like, yeah, you're still going to have this issue if we put this in here, right? Like, this isn't going to fix that, right? Here's what you would need to fix that, and I can help you find somebody. We don't do that. But like, how many times have we gone in or have you guys gone in and proposed a solution to a problem by improving their HVAC system, but not have it solve the problem, right?
Oh, yeah.
Even just correctly diagnosing the issue, even if you don't have the solution for it, I think can be a useful skill in the world of HVAC. So I'm putting a lot of training material together on that, starting to do a little more training. You'll see me out in the world on YouTube here one of these days, pretty soon, couple months. Mostly going in with stuff like that. I think it's a very deep well to go down, and it's where a lot of the problems are, like mystery problems, like, because there's not a whole lot of education out there unless you want to step out into that other industry that focuses on HVAC, but helps us learn about why the building is screwing us up and not the system itself.
100%. I mean, the longer I'm in it, the more I realize that building science is as important as the HVAC side, because everything about that building dictates what we have to do as HVAC designers or installers or what have you. So, and to your comment, I mean, I can't remember how many times I've seen guys say, well, I've got a room in the back that doesn't cool very well, and the salesman just wants to sell them a higher SEER unit to fix that. I'm like, there's nothing about that 20-something SEER unit that's going to fix the airflow. You have a bad duct system or whatever the cause is. So,
bad ductwork. Give them variable speed. That'll fix it.
Right. Yeah.
Good God. Clean CM motor. It's all good.
Yeah. It's and it's a bit of a daunting task, but actually the thing that I'm sort of most known for is, most people call me like the load calc guy. And the reason I find myself in this position is because load calculations are like the best place to start in building science. Like, that's building science, man. Like, it's where are the things coming into my house that are making it hot and cold, right? Like, that's what Manual J is. And that is the largest cause of discomfort and issues. And Manual J breaks them up into pieces. Like, if you understand the process of Manual J, you can't help but learn a lot about building science. If you're trying to understand the process, if you're just trying to learn how to click the buttons or enter the numbers or whatever it is, you're not gonna achieve that next level. But if you stop and ask why or stop and ask how at various steps of the way, you can't help but learn this stuff. Like, that's what it is. It's a great framework to build it around.
Well, I know Philip and I both, and I'm sure you as well. The trend for improving the envelope, making the houses tighter and tighter, and reducing these loads. I don't know the term is mine or whose ever. It doesn't matter. The term of this low load structure that exists now, and I'll give you an example. Some homes that I used to do as an HVAC contractor in the state of Florida required, according to Manual J, required roughly a 10-ton. There's your words for you. 120,000 BTUs of air conditioning in the Florida market. That same house is being built today by the son, not the dad, using different methods. That load's reduced to 39,000 BTUs in that home. That's 2/3 smaller than it used to be. That's a problem when you try to move that much air through that conditioned space and through that footprint. And so there's a whole set of issues associated and arising as a result of these low load structures as well.
So if this ends up on some sort of video format, you all will have noticed that I, while listening to Terry turn my back on him to look at my bookshelf, I have a large stack of books to my left you can't see, and those over there. Somewhere in this stack, I have a book called the Manual LLH, which stands for Low Load Homes. There's a definition. I can't remember what the definition. It's either like 1,000 or 1,200 square feet per ton is officially a low load home. But I mean, it's a vague enough term that, we just kind of have a rough idea. And it talks about implementing some of the stuff. It's an ACCA manual. It's like the Manual J or the Manual S or Manual D, but it's not 100% like that. It's published by them. But Manual J and Manual S and Manual D are procedures to follow that, get you from point A to point B in terms of results and best practices. Manual LLH is sort of like a list of strategies for dealing with some of these issues, right? Like, It's one of my favorite things when we do like a load calculation in class, and the numbers can be, we do it for new construction. The numbers come out and it's like, no way, man. You've got 900 square feet per ton going on here. There's not a chance we're going to do this 1,800 square foot house with 2 tons. Yeah, you are. All day, every day, no problem. But I like to tell people, like, you may have a point here. Like, it's not like there aren't going to be problems here, but we just got to identify what they are. It's not the tonnage. It's not the capacity. We've added insulation. What happens when you add insulation? You need less heat. You need less cooling. Like, we know that. Like, the fact that it's actually going to require less to keep it warm, keep it cool, if you separate that from your initial reaction of, nope, that's not going to work, you can start to break it down and look at, like, what about it might be problematic. And it's not necessarily, in my opinion, that you don't have enough air. It's that you don't have good enough air circulation, right? You can potentially have stagnation problems, right? And so what that means is we have enough air to get the cooling and heating in the house that is needed. We have enough heat and cooling to keep it comfortable. What we might not have is something to mix the air in the spaces. And so when we used to be able to get away with, 2 grill sizes for every application, right? This grill size for anything under 100 square feet, this grill size for anything over. We probably shouldn't be trying to do that anymore. And should maybe be looking at, like, higher quality grills when you have a duct system. Or everybody hates it when I say this, but not everybody hates it, but a lot of people hate it when I say this. Or we maybe start to reclaim those ceiling fans as our turf, because eventually you make your house big enough and you get that load low enough, there is no way to actually mix the air in the room without making your grill sound like little rocket ships. But that's your problem, right? And being able to parse that, like, you guys are a mini split manufacturer. When somebody wants to put one mini split head on one side of a 30-foot room, and expect an even level of comfort in that room, like, you're not going to be pleased with the result. So what can we do, right? Can we, put it on the horizontal wall and center it better and mix the air that way? Can we find a secondary where to mix air using some sort of fan strategy? What have you? Maybe using not using a wall hanger and using a ceiling cartridge just so that you can get air on both ends of the damn room. Like, by identifying, like, by parsing out the different jobs of the system and thinking about, like, okay, well, does this track, does the size actually, it might be, right? We've added insulation, our windows are great, okay. So that means the amount of airflow, should be good in retrofit. That's a big one, by the way, right? Like, okay, you've determined this is what you need, and you're going to use that existing duct system. Is there enough airflow is a really big question. In new construction, not so much. You're in control of that, right? Or for the most part. But in a retrofit job, you're going to play the hand you're dealt on that one. And that can be a real tricky one. And then, is there enough mixing? Is there enough, mixing of the air? Those are sort of the, knowing how much heat and cool the building needs, knowing how much heat and cooling the system gives you, separate job, by the way. Knowing how to size the ductwork to get it there, and then knowing how to mix it once it gets there. Those are sort of the key elements of the system. And if you think about them in those separate pieces, you can better understand where the problem is, so you can better find a solution, right? Because that house, we can't just put another 10 ton in it, right? Like, especially if it's in Florida, good Lord, right? Turn the place into a mold farm. But it's not like we won't have some issues when we make these changes. Right. It's like the law of unintended consequences, right? Like, or sometimes I like to call it, I actually did a presentation a couple of years ago for Brian Orr called Building Science Whack-A-Mole, right? Because every time you solve one problem, another one pops up, which is why you have to categorize these things and just sort of think about them individually, because you can't do what you used to do, but doing something different is going to change outcomes. And so deepening that understanding can be really, really valuable, especially when you're, like, changing technologies, you're electrifying, right? Like, the airflow that frankly, you'd have a problem with modern furnaces, by the way. But the airflow that you were getting through that, that old cast iron furnace or whatever the heck it is, could be completely inadequate, and the homeowner would have no idea. And then you replace it, assuming that the old system worked. Well, it didn't. The standard of my homeowner isn't complaining is not exactly a high bar, right? So like, yep, no, the homeowner seemed to be happy, but was it working really? Because if you go in and say, yeah, well, everybody seemed to be happy, and assume the ductwork has enough airflow, and swap it out for, a heat pump that doesn't have nearly the amount of delta T moving across it. If you can't move enough air volume, you're going to have a real problem on your hands. You'll have a different problem by going with a modern furnace, but I mean, look at the temporize capabilities of a modern furnace, man. Compare it to what you used to be able to get. Do you know how many units out there are running based on a limit trip? Right? Like they're literally every day cycling on and off on limit trips. We didn't have the safety features that turned it off permanently when I have 3 limit trips in an hour. Now we do. So it's not changing the tech that's going to be your problem. You're rolling a truck in either way. But yeah, understanding that airflow and what you've got, huge part of the process, especially in retrofit.
I smell another podcast coming.
Yeah. That is the problem with talking to me. Sorry, guys.
No,
I
it's awesome.
get on a roll, and here we are.
No.
But yeah, and so if you're looking at it from a manual J, manual S perspective, manual J being the load and what the building needs, and manual S being what the equipment can do, there's a theory, and it again, this is an unconventional business model for HVAC contractors. But it can be a lucrative one, a productive one, especially as federal money rolls in for paying for things like this. But you figure out what the airflow is, especially if you're in an area like I'm in I grew up in the Boston area. I live in Western Mass now. So the Northeast, we got a lot of ductwork in the walls. So changing out and improving a duct system is a very expensive proposition. And mini splits are a very useful component of finding a solution there. Refocusing the duct system and blocking off parts of it so that you can use smaller airflows to the parts that you have, and then supplementing with mini splits can be a good solution. But so can the person who explained it to me said, why bring the system to the house? Why not just bring the house to the system? Meaning, okay, well, I can move about 2.5 tons of air here, and I need about 3.5. What could I do to this building that would make it need 2.5? Because replacing that ductwork is going to cost $1 bajillion. You could spend that money making the house better, and maybe spend less than that money making the house better, so that is enough airflow. It's a real interesting approach to the problem. It's not for everybody, but identifying the fact that it's a problem is for everybody, because you're going to get stuck with it, whether you like it or not. So it's something that I like to recommend that if you're doing anything with ducted retrofit, you very least do a static pressure test before you swap it out. Which I know for a lot of people that's a salesperson out there, but we can teach them how to drill a couple of holes and put some tubes in. I think, hopefully. Yeah. Don't let them use the unsheathed bit, but other than that, we ought to be able to do it, and it can just help you figure out whether or not you're about to, stick your foot in a hole, right? And that's all just trying to do the manual J.
Yeah. So back to the salesman who's out in the home, who may or may not have a lot of knowledge and a lot of experience, and we see them across the board, whether they have zero knowledge or they've been in the industry a long time. So the knowledge gap is pretty wide there.
Yeah.
And we've got guys that they do a manual J on everything they touch, no matter what it is. And then we've got guys that are, hey man, if it's got a 3-ton in there, we just go back with another 3-ton. Or, I live in X state, so we use so many square foot per ton. I mean, we hear it all the time. I was in I was in Louisiana when I got into the industry, and, down there, everybody wanted 500 square foot per ton, or if they were, a Cajun dude, he's like, I want bigger, better. So I want 400 square foot per ton in my house. And, I still remember sitting them down going, I'm going to do a load calculation. And if you are still going to insist on the size that you think you want, then we're done here. You're going to need to call somebody else and find them. So, other than, we'll call it ignorance, and I don't mean that in a negative way, just not understanding, what are some of the things that you see as you've met hundreds and hundreds of students? Why are professionals not starting with the basics and even doing a load calc on a home?
Well, there's a lot of reasons for that, in my opinion, in my experience. One of them is a lot of people's first, and maybe this isn't as true today in the South, but a lot of people's first experience with air conditioning is a window rattler. And the U.S. government provides guidelines that are based on square footage. It drives me up the wall, actually, that that they still publish that at a. Oh yeah, you guys make appliance level stuff. I forgot.
Yeah.
And so it sort of just sets the tone with the customer, but even earlier in your life, before you were an HVAC guy, maybe with you. Right, to think about it's the size of the building that counts and not the size of its exterior surfaces, which is really what it boils down to. The size and quality of the exterior of the building is mostly what you're after. And so I think that's it. Like, you just kind of start off on that foot. And then when we bumped into each other last, we were at ESCO, which is a group that works a lot with trades instructors. And I love going to that event because I get to talk to the people who are doing the frontline work, right? Putting in the effort and training our next generation of techs. And they get a lot of flack from existing contractors for teaching these kids ways of doing things that don't jive with the way that those companies have always done things, right? Like, you think, the injection of young blood would be the, one of the, solutions to this, but in some cases you have these instructors who are trying to partner with them. This job placement is a huge part of trades education, huge. And so if all the local instructors are like, no, show them how to use the tools. We'll figure out how to size it. Let us worry about that. They skip the step where they get that education, right? The focus is on being mechanically inclined, right? There's a lot fewer people grow up working on a car than we used to have. And so a lot of times literally teaching them how to use some of the most basic tools is a necessary part of the education. I'm not saying it's not, but it doesn't always leave time for some of these higher concepts. And then there's at what point in your career do you take a step back and fill in some of these gaps? You end up being responsible for it yourself. And if you want to advance that career, you want to be better and better all the time, look for that, right? Find ways to get that advantage. Easiest way is pick up a book or go on YouTube or pick up a podcast. There's a bunch of us out there doing this stuff. But yeah, it's the people who aren't doing it were often failed by somebody or by something. And the person who failed them oftentimes had troubles of their own, right? Like, it is hard to change a tire when you're driving 55 on the highway. But it establishes this sort of baseline. And then there's that thing I said earlier, where the homeowner isn't complaining is a pretty low bar. Is something I say a lot, because there are a lot of people out there who think they're doing good work. And I'm not here to tell you that none of you are doing good work out there listening, but the standard by which we judge that, and it makes sense as a standard. My customers are happy. That's a pretty good standard in terms of a successful business. My customers are happy. right? But it turns out that you might want to understand things a little deeper than that, because there can be reasons that those customers are happy that are slowly killing your system, right? Like, it's oversized and it's underducted. What does that do? Well, it's oversized, right? Well, how much capacity do you get out of the system if you don't have enough airflow? A lot less. Well, now it's a lot less oversized. What's the biggest problem about having a short cycle? Humidity. What happens to the capacity of the system when you give it less airflow? It becomes better at dehumidification. So all of a sudden, this doesn't look like a problem anymore because the homeowner's not complaining, right? But slowly that compressor is getting murdered, right? Like you are, and that ECM motor too, potentially, which is a much more expensive repair than it used to be. But we can chug along in this industry making complementary mistakes that look like success.
Yeah, I saw tons of those oversized system, typically an undersized return. You'd have a 4-ton machine with a 14-inch flex return on it, and this is in the South where we use a lot of flex. And yeah, it actually worked pretty good as far as dehumidifying the home because they only needed 3 tons and you were choking the thing down. So, but to your point, it killed the system prematurely. So, part of giving the customer what they're paying for is giving them the full life of the equipment that you're selling them, Yep.
Yeah. And it's, and for the folks out there that, they use that standard of my homeowners are happy. I'm not saying it's a bad thing per se, but it's not a complete look at why things are quote unquote working. And when you only can see part of the picture, you may not realize what happens when part of it changes, right? Like that's the thing, is eventually they change just the right thing to break it, right? Yeah. You have this weird balance of mistakes that are making it, a comfortable environment, if not like the ideal scenario for your HVAC system. But they change the refrigerant on you, they change the SEER rating on you, they change the fan technology on you, whatever. Those things have consequences. And if you aren't in control of every single piece of this, sometimes the consequence is stuff stops working. And it's, it's one of the things I like to, on the new construction side, like there's crappy equipment out there for sure, but they published the book that tells you it's crappy, and it tells you exactly how and why it's crappy. And there can be times where somebody is on a budget and the thing that makes it crappy, that it maybe is bad at airflow, you can counter that, right? You can add a return to that system. And now all of a sudden the fact that it's bad at airflow, well, we've done something to compensate for that, and we can make it work, right? Like literally, it's the motto over there at that other podcast, right? RTFM, right? Read the fantastic, is what they say. We all know it means something different. Manual, right? Open the books, right? Have a look at them. There's a lot of information out there, and this is, you guys are a manufacturer, led podcast here, so don't take this too personally, but I like to say it will tell you where they suck. They are telling you every day all of the places they suck. You just have to look, and when you can identify how they suck, like exactly what makes them suck, you can often compensate for it and actually make it not suck. You just have to do something a little different.
Right. We'll call it limitations.
Yeah, limitations. Yeah. I like to speak a little more plainly.
It's all good.
Especially since I don't have a background from the field. If I add to that the corpo speak, no one's going to listen to a word I say. I don't blame it. And I wouldn't blame.
Right. So going back to what you were talking about, and I kind of want to keep, there's so many directions that we could go with everything that you've talked about, but let's go back to the load calc issue. Yeah. You're a young guy, you've come out of trade school. They didn't teach you load calculations in trade school, which unfortunately is true at some of them. I had a meeting one time with the trade school. They wanted me to be on the advisory board, and I was just talking with some of the instructors trying to understand what's the curriculum like. And I said, "Do you teach load calcs?" And his answer was, "Oh, absolutely we do. 400 square foot per ton." and I mean, my jaw about hit the floor.
Mm-hmm.
I was like, wow. So, you know, I understand there are some very, very excellent trade schools and instructors,
Yes.
and I appreciate them. But you're a young person in the industry, or heck, you've been in the industry a long time, and you go,
There you
okay,
go. Yep.
I realize I need to understand load calcs because I don't do them. I'm one of those guys that I change it out with the size that's there, or I use a rule of thumb that was passed down from somebody that got established 75 years ago. Where would you tell them to start the education process where would you start? Where would you go first to learn how to do a basic load calculation? What's step 1 and step 2 and step 3?
So, and this is something I struggle with a lot, right? Because you can't start doing one thing better if a series of bad things working in complementary ways is the only reason it's working now. Like, it's really hard to just learn a little bit about the load calculation and somehow implement that in a successful way. I've always wanted to be able to break up my trainings into, here's a basic manual J, here's a little more advanced manual J, here's a manual S, here's a manual D. But you could know exactly what the load on a house is. If you didn't know that AHRI data is absolute junk, you might put the wrong system in. And if you put the right system in, but you don't size the ductwork properly, it doesn't matter. And every step of the way, and this is something I learned, because we did that a little bit at RightSoft every once in a while. We would just teach a load class, and what you end up getting is a lot of people who make different mistakes after that and then blame the load calc. I knew that load was wrong because it didn't work, but it didn't work because that 3-ton unit in your location only has 29,000 BTUs of capacity to it, or it didn't work because it wasn't getting enough airflow, or it didn't work because the filter was murdering your system, or whatever the heck it was. So it is tough. And it's something that I would caution you about, not necessarily how you learn, but how you implement. Like, I would suggest you have an understanding all the way through load calculation, equipment capacity, and airflow before you start making drastic changes in the types of decisions you make, right? Better is better is a thing that I'm fond of saying. But understanding what worse things are working together in complementary ways is the thing that gets in the way of that. So I try not to be super self-serving and say, you know, come to my website and sign up for the HVAC Design Academy, which I can never say with a straight face. But it's what I called my my training program. But there is some stuff out there. And probably the cheapest and most direct way to do it is to buy a book, right? Like, one of the things, if you want to understand concepts and you are intimidated by large books, most of you are experiencing this in an audio format, but this big old sucker is the current Manual J. A lot of what's in there is tables that you absolutely don't need to read. You buy software to do that, right?
Right.
Like, even the math, right? Like, it's good to understand some of the basic stuff, but like, it's the explanations that you want to read. You can get software to do the math for you, right? Like, my first YouTube video, maybe it's out by the time you're listening to this, is very likely going to be the only psychrometric chart you ever need. And it's not a psychrometric chart. It's just something that says, when you add heat, temperature goes up. When you add moisture, humidity goes up. Like, and then use a calculator. Right? They make a bunch of them. Let the software do the hard work. Don't force yourself into that if that's not your thing. Some people like doing the math. They understand it. That's awesome. You know that about yourself. But if you don't try to turn yourself into that guy. Just try to read about on the concepts of this stuff. But understand that these are things that work together. That these are, like, I wouldn't go out and start overhauling the way you do things, just because you ran something through an online quote unquote load calculation tool. Those can be valuable in certain ways, but generally not as like major technical tools. And there are other parts of the process. So I would suggest keeping an eye, like postmortems are a great thing. Like, okay, this didn't work. Why didn't it work? Right. And try to run it through was it the building? Was it the system? Was it the airflow? Right. Like, and categorizing things in that so that you can identify areas of need. The process itself, you start with manual J, you move to manual S, and then manual D. But if you don't have all three at the end, you run the risk of making it look like the part that you did implement is what screwed you up, when really it was one of those other steps. So you can start with the books. ACCA is a great organization to follow. They have a trainer. His name is Ed Janawak. He has weekly, monthly, I don't know, like video trainings out there. I'm going to start putting out some more free stuff because I think it's my goal is to be able to give everything away and still eat. I haven't quite figured out how to thread that needle yet, but I'm working on it because I would love it if I could put more of this training in front of more people. But ACCA has some stuff. The books are a little cheaper than the full trainings. They can be a little intimidating. See if you can find a used copy of Manual J7. It's the older Manual J. It's a thinner book, a little bit easier a little less intimidating. If you carve out all the tables from this thing, it's actually a much smaller book, but it still can be a bit of a slog. Let's see, where else could you sort of get your start? Like YouTube's is a good thing. If you're dealing with somebody who's a little more, shall we say, reputable, find out, what their bona fides are, right? There's this is Jimmy, and Jimmy has an iPhone, and he's going to tell you everything he knows about HVAC, which is nothing.
What? While he's driving down the road in his van.
Yeah.
Station wagon AC, baby.
There's actually a kind of a lot of information on like social media. There are like Facebook groups dedicated to using the various load calculation products out there. RightSoft, Elite, CoolCalc, like they all have like groups of people on social media sort of trying to support each other. You have to fight through this guy said one thing, this guy said the other thing kind of stuff, but you can generally go through old posts and kind of see who won to know who are the active, trustworthy people. There are some, he can get a little technical, but in terms of making the technical accessible, he's pretty darn good. There's a blog done by the name of a guy called named Allison Bales.
Mm-hmm.
It's called the Energy Vanguard blog. And
he's in my neck of the woods.
Yeah. He's down in Atlanta, and he writes a lot of really good stuff. He lives in the intersection more than I do. He lives where I want to live. He lives at the intersection of HVAC and building science in a very big way. Just read an article a day or something, right? And you will learn a lot about. He started off as a physics teacher. Like he's got a degree in physics. He understands the true fundamentals of what this stuff is, and can explain it. When they hit you with the math, it's okay to glaze over, right? It's okay to look at it and go, "Ooh, scary formula." Next, because no one's going to ask you to take out a pencil and paper and do that math. They have tools for that. What you need to understand is what goes in, roughly what happens when it goes in the magic box, so that you can understand the number that comes out. But knowing how it's important, why it's important, what it's doing, all of that stuff, that's all really important stuff. Like, let's see, there's, it's a little more, you kind of have to search for the nuggets that are very HVAC related, but Building Science Corporation has a blog as well. It's got some good stuff. We don't really have, and HVAC School is another one. Weirdly kind of a competitor of yours in the podcast space, but I'm sure you are more than willing to share the room with Brian Orr and them. And they do a decent amount of discussion on this, but most people who teach this stuff, I mean, really, you should spend like a semester doing this, right? I mean, like it's not a small thing. So most of the places where you can get good education on this, it is going to be a bit of a commitment to your time. I've got my on-demand thing. I do live classes. I do one-on-one. Don't ask me to train you how to do this one-on-one from scratch. It's a waste of money, way too much time, way too much money. Watch the videos. Some of the various software companies will have their own training materials. I have, when I left RightSoft, there was a lot of recorded material from me. Its organization isn't the best. But I'm not going to say that I was holding back when I was working there. So that stuff is available. National Comfort Institute, they don't do a lot with like load calculations, but it's, good, solid technical training. Let's see where else. But yeah, literally just picking up a book and starting with the ACCA, if you want to dip a toe in, is probably a pretty good place to do it. Like I said, I just would warn you about the moment where you're like, I learned this new thing out of context and I'm going to overhaul the way I do things. And no, it didn't work. Before you go blaming the change that you made, if you didn't look at all the parts of the system when you were making those changes, you are running the risk of having a problem over here look like a problem over there.
So if I hear you, and I think I do, this isn't one of these, I'm going to go take a class and understand it all and be an expert. This is one of these, if I want to be better, if I want to improve my company and I want to improve my skills and improve my value as an employee, this is a topic and a subject that I need to dedicate some serious amount of time to learning and to understanding the whys behind it. Why does a small return do what it does? Why does it cause the system to dehumidify, but also cause the airflow to go down? Why does it cause the amperage to go up? Why does a gap in insulation cause heat to do what it does? There's so many whys that, we can make a load calc say whatever you want it to say. I mean, I've had guys go, I remember one time I needed another company to do a load calc for me, and I don't even remember why. And he goes, okay, what do you want it to be? Yeah. He goes, what do you want it to be? I said, what do you mean?
Yeah.
He goes, well, tell me what size unit you're going to put in there, and I'll give you the load calc to match so that you can turn in the manual J. And I was like, oh my goodness, this is so broken. This is so backwards that's what's happening. And it's given a black eye to the industry unnecessarily. And
I should probably walk back a little of what I said there, because for real, better is better, right? You just have to understand that there are interlocking parts of the equation or of the literal system, right? The whole house is a system. Mm-hmm. And if you put blinders on and attempt to learn this one thing like it's the gospel, that's only a part of the process that's going to solve everything, you're going to be disappointed. But you also don't need to be the 20-year expert to better size a system, right? Like, that's not necessary at all. Once you have a relatively good understanding of load calculations, and it doesn't have to be that deep, on a whole house level, these things come in 3,000 to 6,000 BTU increments, depending on what type of system they are. Like, there's some room for error there. And if something was a ton oversized and you put in a system that's only half a ton oversized, it is going to be better. Right?
Better's better.
Yeah, better is better, right? It's just, pardon the expression, but it's going off half cocked that you have to watch out for. right? It's when you're like, I get this now, and I'm just going to apply it and expect I can overhaul, make huge changes to the way I do things. That's how a lot of people get burned in this process. I love it when people dive in with 2 feet. And and sometimes they succeed doing it, but you do want to be careful what that implementation looks like. And you want to make sure those are the parts of the system, right? What does the building need? What does the equipment do? How do I deliver the airflow? And a part of that also is how do I mix the air? And if you feel like you have a handle on those 4 things, then it's amazing the sort of things you can diagnose, the decisions you can make, the places where you can save or adjust or like break it down into those pieces, and you'll be pretty good. But if you only have one of those pieces and you're really not sure about the other ones, be careful how much change you start to implement. That's all.
Yeah.
Right. The information you learned is good. It's just don't put, if you break a leg and, you've been in a cast for 6 months, don't put too much weight on the leg. But it's, like if as it's building up its strength, you don't want to lean on it too hard. That's all. Because a lot of this is some pretty basic stuff, right? If there's one thing I could teach somebody about load calculations, I know you're supposed to be asking the questions here, but I'm gonna give you this one.
Go for it.
If I had one thing I could ask, or I could teach someone about load calculations and duct design and its system efficiency and everything else, it's the law of diminishing returns. Okay. And the likelihood that I have a mathematician listening to this is probably pretty low. But technically this specific law of diminishing returns I'm referring to is called the inverse law, or the inverse curve. And what it means is when something is terrible, it's real bad, like real bad. And when something gets just a little better from terrible, the results, the return on that investment is incredible. And then you get a little better, improvements, okay. And then you get good. And yeah, okay, there's a jump there and you notice it, but then you get great. Man, that barely moves the needle. Like, Now that's not an excuse to not be great, but sometimes it's enough to not be terrible, right? Like, actually, this is one of the, let me explain in a way that the listeners can actually use. Next time a homeowner says, but the other guy has 16.5 SEER, you're only 16 SEER, and you want to just like shake them to be like, it really doesn't matter. A good way to get anybody to understand the law of diminishing returns is gas mileage, right? If you commuted to work in a school bus and it cost you $100 a week in fuel, and it got 5 miles to the gallon, and you traded it in for an old pickup that gets 10 miles per gallon, you save $50, right? You trade that in for a newer pickup that gets 20 miles to the gallon. Well, you've doubled the increase, right? First time you went from 5 to 10. Now you're going from 10 to 20. You only save $25. And when you go from 20 to 40, you increased your MPG by 40. Now you're going from a pickup truck to a compact car, and you save $12.50. Right? If they made a hybrid that got 80, and you increase your MPG by 40, you save $6 and change. Right? That law applies to so many things in the world, but in the world of building science and HVAC, it's ridiculous. When you are in the school bus, when you're in the uninsulated home, you add a little bit of insulation and oh my God, do you see a return on that investment, right? When I see somebody who has good insulation in an attic and then pays good money to have somebody add to it, you got hosed, man. Like I'm not saying it's not nice to have more insulation up there, but you should find the weak point, right? And so like that's a good way to approach it, and a good model for thinking about things is if we just tried not to be terrible, or if we just identified the things that are the most terrible, that's where you're going to see your biggest results.
And I think that's the beauty of some of these softwares is we can pretty easily figure out what's going to give us a bang for our buck. You're sitting there with the homeowner and there's like, hey, want to make my home more efficient, I'm thinking about adding, to your example, insulation in my attic. Well, you've already got R19 and you want to go to R30. It's going to drop your load by, you can tell them exactly 4,000 BTUs or whatever it is on their home. But hey, if you would look at those western windows over there, maybe you can't afford to do all the windows of your home at one time. Let's just go grab those western ones that are baking in the afternoon and upgrade those windows. What would that do for your home? You could mathematically tell them, hey, it's going to take this percentage off of your cooling load.
Yep. And
so,
you know, and you can, and that you can back that up further, right? You could be fresh off of reading that chapter of the Manual J, and you don't even need to read the Manual J for this one. I don't want to insult anybody's intelligence on this. All right. But you could say to that homeowner, hey, how about we close the blinds in the afternoon? Right. Like that will solve our problem in the short term. Right. And you can, or we can tear up this duct system, do this right, and it'll cost you $2,000. Or you can close the blinds in the afternoon. Yeah. Like, don't let perfect be the enemy of the good. Right. But identifying the source of the problem, that's where it all starts. Yep. Right. Like that's sort of the key. And so I apologize. I've done a lot of tap dancing here to try to avoid saying, get some software and get some training from me or from somebody like me. But that is probably your best bet, right? Yeah. Like I don't want you to do the math. I want you to buy something that does the math. I just want you to understand what happens when you use it. Right. And reading, buying books. Actually, Allison Bales has a book somewhere behind me. Sorry, I can't. A House Needs to Breathe, or Does It? Mm-hmm. Is the name of that one. And it answers a lot of questions that guys have, like, how do I know how much insulation's in the wall? There's a few ways to do that. You can take an outlet cover off of an exterior wall and look between the gang box and the wall board. Because you know what? I don't care if it's R11 or R13, right? That's pickup truck A and pickup truck B. We're talking like 2 MPG, right? I care if it's R0 or R11, right? Like that's where the big thing is. Mm-hmm. When I'm looking for something like that, I'm not looking to know exactly what it is. I'm looking to know, is it there? Am I in the terrible range, or am I in the, like, okay, where it doesn't make a hell of a lot of difference range? And by the way, if you're doing new construction, take the crash course. Okay. Dive in, because there's too many things changing. It's too hard to do this well without a design software, without a RightSoft and a Lead, a quick model. You need it. And if you're going without, the kind of trouble you can get yourself in is pretty big. In retrofit, you're dealing a hand that you were dealt, and you don't always get perfect outcomes. And that's sort of built into the process, right? Like we're not trying to make perfect, we're trying to improve. You might be trying to make perfect, but hey man, if you're going to try to make perfect, you need to have this stuff under your belt. But there is space for getting better in that situation. But if you're doing new installs, right? If you're in a situation where we're talking about, how much difference would it make if we increased our insulation or did this or that? If you're in that boat, I would highly recommend that you pick one of those platforms and take their free training at the very least, because that's the right place to start if you're already making those decisions, particularly in the new construction world. I'm not saying it's in any way better to be screwing up in retrofit, but in retrofit, a lot of the screw ups are already there. And when it comes to how do I fix something, understanding concepts is a lot more useful than, say, software. Right? Software is still useful for sure, It helps you quantify, your problems, but you can't always tear out all that ductwork, right? Sometimes it's, you can't always pick the exact CFM that you want. Sometimes it's like, this is all I can get. How do I make that work? And it becomes a lot more conceptual than mathematical. So yeah, if you're in new construction, I don't think it's a baby step kind of thing. I think it's bite the bullet, get the training, do an immersive thing, try to bring yourself up to speed, and go with that. In retrofit, you got a little more wiggle room.
For me, it's a little interesting. Florida has long been a state, and several of these states in the South, where you can't build a home without a manual J load calc attached to the set of plans and submitted to the building department for your permit. And then there's energy. I travel like Phillip when we're in different parts of the country, and I'd like the state of Washington, for example, has recently enacted a bunch of code changes to the home construction. It's making it nearly impossible for HVAC contractors to properly select and size a system. I mean, it's this craziness that goes on in some of this stuff. I can't remember, Alex, if it was you that said to us that all the science guys, all the building science guys, are hippies, all live in dry climates. Was that you that said that to us?
Yeah, sort of. Yeah, a
Yeah,
little out of context.
yeah,
Not all of them, but there are a lot of them who
certainly.
live in very dry climates and are very
So
willy-nilly about how much outside air they'll bring in, and get very and then ironically they get really annoyingly picky about like capacity numbers when like yeah,
CFM, they
like
get all wrapped up
they're-
in CFM.
yeah, it's like seriously guys, it's a dry climate, like don't undersize it. Don't oversize it either, but I mean your wiggle room here is so much bigger than it would be in Florida, right? It does not take much in Florida to start causing water problems in the home, right?
Right.
If you
Or
are having
Louisiana.
a condensation water problem in Washington, you screwed up on a level that is epic, right?
So that's a
Like,
big change from terrible to
yeah,
oh.
exactly. The stakes, so if you're listening to this and you're in Florida or Alabama or Atlanta, one of these areas, in that high humidity, hot zone, yeah, sorry guys, stakes are higher, right? When you make mistakes, the consequences of those mistakes can be more dire. And unfortunately, once upon a time, like 500 square feet per ton is what they were using in Louisiana when you came up, right? You know what they were using in Massachusetts? 400 square feet per ton. Yeah. So how on earth is that going to be the case? Well, it's going to be the case because in Louisiana, if they used 400 square feet per ton, they were growing mold in the house, right? Like they bumped up again. We have a super short summer, and homeowners who like to keep it at like 65 degrees because they're all used to the cold weather. And so it doesn't provide enough time for that buildup, but in Louisiana, it does. Right. And so there's a little bit of that baked in. It used to be the case, and it was, everybody's got that homeowner, right? Can remember way back when. But it used to be the case if it was dry in a house and temperature went up a couple of degrees on the hottest day of the year, that nobody freaked out when you lived in a climate like Louisiana. Now the expectations are higher, right? Now the homeowner is like, I bought this thermostat online and it says it's 76 degrees and the box you put on my wall says 70, whatever. Like, I know that is now the case, but that just means that if that's going to be your customer's expectation, you may have to dot a few more I's and cross a few more T's, which sucks, but that's where we are. So yeah, there is a lot to learn. There's a lot to it, but it does have some really basic like concept. Like he comes through insulation and through the air, right? And then through the sunlight coming through the home. Like, there you go. You got your three categories, right? Mm-hmm. They're called conduction, convection, and radiance, by the way. And you can, why is it hot in this room? Well, is it conduction? How's the insulation? Is it convection? Is it very leaky? Is it radiance? Do we have a lot of windows? Ding, 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 ding. There we go. There's our problem. Like,
Yep.
you can really high level some of this stuff, but if you want to, you want to leverage it, you just keep pushing yourself down that rabbit hole.
Right.
There's a ton of information out there. And I would like to be somebody who wrangles it up, puts it in a place that everybody can have access to. I'm just trying to figure that out now.
Well, we appreciate the work that you're doing. Appreciate you hanging out with us today. We've covered a lot of different topics, probably more than Terry and I expected to get into. But
your editor is going to have a lot of fun with this one. I apologize to whoever that is.
Oh no, it's
all
legal.
Good. It's all stuff that needs to be covered, right? Because
Absolutely.
we want to talk about load calcs. Well, load calcs opens up so many other, call them rabbit trails, but really doors that we need to go down and understand. It kind of reveals how big some of this actually is. So
Yeah.
So
never stop learning, right? Never stop learning.
here's my thoughts for what it's worth. All right. You just spend an hour saying to folks, listen, HVAC matters. Okay. Comfort in your home matters. Spending 2 years at home during COVID has made that very aware
Yeah.
to the US consumer. And so if you're listening to this podcast and you're an HVAC contractor, or consumer, whoever you are, understand that using the tools that are available, whether they're tools that we use with our hands or tools that we use with our mind, these tools give you the opportunity to select, make, and install a better system for folks. And I think ultimately that's what we're after. I know LG Electronics, we make a fine piece of equipment. When installed properly, like most stuff, works great. You can read the internet for when it's not installed correctly, right? So, and it doesn't limit just our brand, right? You can go right down the list of all the manufacturers. So, using the tools, understanding the applications, applying the science that you learned, and I love your term at the intersection of building science and HVAC. I think that's a way underutilized term and perspective in our trade. So I'd like to say thanks for the stuff that I learned today. Always a pleasure.
It is my pleasure. And I'll give you a parting thought. Early in this conversation, I talked too much. This is entirely my fault. But earlier in this conversation, I figured it would be the LG people who chimed in with this one. Variable capacity doesn't mean don't worry, it'll ramp down.
Are you sure?
We weren't. That's not. Are you sure?
I was taught you can never oversize a mini split.
You could just
legitimately
You're
told
wearing
that.
that logo on your shirt. You got to be careful,
This was
man.
long time ago when I was
know.
told that, and it was not by an LG employee. I'll tell you that.
Yeah.
Yeah, but you're right.
Yeah, it is. And if you haven't already had this podcast, because this isn't my field of expertise, but all of the reasons why a system that has been oversized, even though it's variable capacity, all of the reasons why that's a bad idea is something that, we all should be more familiar with, because it is a trap. It's not, I mean, these guys sought me out to have me on because failure to do some of this stuff is causing problems with their product. We could do better.
Yeah, I mean,
Don't let variable capacity lull you into a false sense.
No, when you start looking at these multi-zone systems and variable capacity systems, and I know you run a load calc on a bedroom in the United States of America, and it comes up to 2,000 BTUs. And
if you're lucky,
right, a 12 by 12 bedroom, if you're lucky, and these guys throw a 7,000 or 9,000 BTU head in, and it'll ramp down. Don't worry, right? So that's the biggest black eye with this technology, which is exactly to your point why we wanted you on here to have this discussion that you just can't do this, folks. We have to get better.
Yeah.
Yep. There's a manual S requirement even for variable capacity, inverter driven, whatever you want to call it. There's a different requirement than single stage systems, and it does have a little bit more, we'll call it grace, but really not. Flexibility of application is really more what it is. And so there are definitely a lot of reasons why the variable capacity is superior. But yeah, there's still limitations to it. You cannot abuse it and then expect it to work magic for you.
Right. Yeah.
So,
which is a topic I would love to discuss with you guys, but I feel like I've dumped too much on you to begin with. So,
hey, we'd love to have you back on and pick your brain on something else. Yeah.
Super.
Well, I think that'll wrap us up for today. So, Alex, again, thanks for being with us. Thanks for being our guest today. Check him out on his website, meanhvac.com. Take some time, dig through his material, use him as a resource. Get yourself educated. That's the biggest thing. That's what Terry and I and Alex obviously have at our heart, that we want the men and women in this trade to continue their education. We try to have a little bit of fun here, but we want you to learn something each and every time you come sit in on one of these episodes. So, gentlemen, thank you. I appreciate it. Terry, take it away for us.
Yes, sir. Well, again, thanks for listening today. Alex, again, thank you. LG Procast, we'll be back for a topic near you soon. So have a great day.
Thank you, guys.
See you guys.
Thanks. Bye-bye.